ఛానల్. ఈరోజు మనం బేసిక్ ప్రపోర్షనాలిటీ థీరం యొక్క కన్వర్స్ థీరంని నేర్చుకుందాం. In the previous class you have been told by me basic proportionality theorem. Now I am going to teach and explain about the converse of basic proportionality theorem. So what is the another name of basic proportionality theorem means Thales theorem. So Thales theorem is the another name of basic proportionality theorem. Before going to enter this theorem, first of all, in the previous class which had been learned by you, I would like to remind one more time. Listen to me. So basic proportionality theorem of concept is nothing but this one. Every theorem had been divided into two parts. The first part is given and second part is required to prove. So given part we can take that one as a clue to prove the proof. Okay, that's all. Here actually the statement of the basic proportionality theorem is in a triangle, if we draw a line parallel to any one of the three sides of the triangle, it can divide the remaining two sides in the same ratio. This is the concept of basic proportionality theorem. So in this concept we need to divide what is given and what is required to prove. So in basic proportionality theorem, given is in a triangle, if a line is parallel to any one of the three sides, if a line is parallel to any one of the three sides of a triangle, then this is given. That means a triangle have been given, you can take any name for that, and you can take one line as parallel to any one of the three sides. This one we can take. By taking this concept we can prove. This is given part. And what is the required part? Required to prove. Then what is that part? Then that line which you are taking parallel to any one of the three sides, that can divide remaining two sides in the same ratio. So this is given and this is required to prove. This part we can take as a clue to prove this required to prove. Okay. Here converse means given will change as required to prove and required to prove changed as given. According to that we need to make the statement. The statement which had been made by you in this way, that is called converse of the basic proportionality theorem. Sometimes you have been given in the problem concept, that means statement, but sometimes that statement also you need to write. In such cases you need to write yourself the statement also. For example, if you have been asked a question as in this way, state and prove converse of the basic proportionality or Thales theorem. This is the question. That means here statement also we need to write. Statement also we need to write. So this is the converse of basic proportionality theorem. That means in basic proportionality theorem, given part which you are having, that one we need to take it required to prove part, and the required to prove part which you are having, that one you need to write as given. Now listen to me the statement. Observe. In a triangle, if a line divides any two sides in the same ratio, that line is parallel to the third side of the triangle. This is the statement of the basic proportionality theorem of converse. Okay, if a line divides two sides of a triangle in the same ratio, then that line is parallel to the third side third side of the triangle. So here given part is, first of all we need to take a triangle. For this triangle you need to enter a line which can divide two sides of the triangle in the same ratio. That is the given. In the previous theorem it is nothing but in the proof part, required to prove part, but it came to here in the given part. Okay. In such way, if a line divides any two sides of triangle in the same ratio, that line can divide, that line is parallel to the third side. So the line is parallel to the third side, that one we need to prove here. That one we need to prove here. That's all. Now listen to me. Here I am writing the information which have been given in the statement. Now I am writing. That is a triangle. So draw a triangle. I am drawing the triangle as ABC. In this triangle, one line you need to take. That line here also I am taking as L. That line L dividing these two line segments in the same ratio. Let this line L meets these two line segments in the two distinct points. The two distinct points I am taking here also as D and D. Okay. Now L is dividing the line segments AB and AC in the same ratio. That means AD by DB is equal to AE by EC. In that way L is dividing these two line segments. That's all. In triangle ABC, L divides AB and AC in the same ratio. In the same ratio. That means AD by DB is equal to AE by EC. So this part have been given in the problem now in this theorem. So this one I am taking as equation 1. So here what is required to prove? Here we need to prove the line which is dividing these two line segments of triangle in this way, AD by DB equal to AE by EC. That line is parallel to the remaining side. That means this line is dividing these two line segments in the same ratio. The remaining side is nothing but in this triangle BC. That line is parallel to this BC. Okay. So this L is parallel to BC. Like in this way we need to prove. That's all. Now listen to me. Here there is no construction. Especially you need not to take any steps here to prove that. So directly in such cases you can go for proof. Listen to me. Here this theorem we need to prove in the controversy method. Controversy method means what is our aim? Proving L is parallel to BC is our aim. For that aim we need to take a controversy meaning. So that means L is parallel to BC, that what we need to prove. For that opposite meaning of sense which you get, that formation you need to take. That means L is not parallel to BC. By taking in that way we need to prove that's a theorem. So here let L is not parallel to BC. ఇక్కడ మనం L is parallel to BC అని ప్రూవ్ చేయాలి. బట్ L is parallel to BC అనే కాన్సెప్ట్కి ఆపోజిట్ మీనింగ్ వచ్చేట్లుగా మనం అజంప్షన్ చేసుకొని ఈ థియరంలో ప్రూఫ్కి వెళ్తాం. సో L is parallel to BC అని మనం ప్రూవ్ చేయాలి. కాబట్టి దానికి ఆపోజిట్ మీనింగ్ వచ్చేట్లుగా L is not parallel to BC అన్నట్టుగా తీసుకోవాలి. ఓకే, L అనే ఒక లైన్ BCకి ప్యారలల్ కాదు అని తీసుకుంటున్నాం. బట్ L కాకపోతే ఏదో ఒక లైన్ అయితే అక్కడ ఉంటుంది అదర్ దాన్ L. ఓకే, దట్ వన్ ఆల్సో వీ నీడ్ టు థింక్ ఆఫ్. ఓకే, L కాదు అనుకున్నప్పుడు L అనే లైన్ కాకుండా ఇంకొక లైన్ ఏదో ఒకటి అయితే అక్కడ ఎగ్జిస్ట్ అవుతుంది. సో హియర్ L ఈజ్ నాట్ ప్యారలల్ టు BC, there should be exist one more line other than that L. That one we need to create. What is that one? So if L is not parallel to BC, then one more line there should be exist. That line we are taking as D E dash. That is parallel to BC. Like in that way we need to take. So let L is not parallel to BC. Then D E dash is a parallel line to BC. Okay, now DE dash is parallel to BC. So DE dash is parallel to BC. Whenever in a triangle, if a line is parallel to any one of the three sides, there we can apply basic proportionality theorem. What is that basic proportionality theorem? If a line is parallel to any one of the three sides in a triangle, that can divide the remaining two sides in the same ratio. That one we can use here. So here we are taking this DE dash is parallel to BC. Just we are assuming in that way. So whenever we are assuming that line is parallel to any one of the three sides of the triangle, in that way, that line can divide the remaining two sides in the same ratio. That means AD by DB is equal to AE dash by E dash C. Like in that way we can take. Because of this one we are taking as parallel to BC. Why you are taking in that way means L is not parallel to BC. If you take in that way, one more line there should be exist parallel to BC. That line we are assuming as here DE dash. That's all. So DE dash is parallel line to BC. According to basic proportionality theorem, we can write AD by DB is equal to AE dash by E dash C. That's all. But here now we need to go for given. In this given part, AD by DB is equal to for AE by EC. This is equation 1 like in the way we are taking. By observing in these two equations, the two equations of respective left hand sides are equal. Automatically their respective right hand sides are also equal. Okay, let this equation as 2 from 1 and 2 simply you can write in that two equations when two left hand sides are equal, their respective right hand sides are also equal. According to that we can write here AE by EC is equal to AE dash by E dash C. Here I am adding 1 on both sides. By adding 1 on both sides, by adding 1 on both sides, then AE by EC plus 1 is equal to AE dash by E dash C plus 1. Now AE we can write as it is plus EC by EC, that is equal to AE dash plus E dash C by E dash C. AE plus EC. AE plus EC is nothing but what? AC. AC by EC, that is equal to AE dash plus E dash C. AE dash plus E dash C is also nothing but AC. Is also nothing but AC by E dash C. Now listen to me. Here we are having two fractions. In these two fractions, their respective numerators are equal. Because of AC is equal to AC, according to reflexive property or Euclid's properties, a line segment is equal to itself. According to that, this AC is equal to AC, it can be acceptable. But here, their respective denominators, if you observe, EC is equal to E dash C, like in that way you are getting. So let yourself, you need to check yourself in the figure whether EC is equal to E dash C or not. So EC is nothing but this part. E dash C is nothing but this part. Is it possible? No, it is not possible. But it is possible when E dash and E, these 2 points are coincide to each other, then it is possible. Okay. according to that, that means up to that, it is not possible. So here, by taking L is parallel to BC, we are getting a controversy here. What is that controversy? EC is equal to E dash C, like in that way we are getting, but EC is not equal to E dash C. When that two line segments are equal means E and E dash are coincide to each other. Okay, but here we need to write that EC is not equal to E dash C. They are equal. They are equal when E and E dash are coincide to each other. So our assumption is wrong. So our assumption what is our assumption? L is parallel to BC is wrong. So which is right? L is not parallel to BC. That means L is not parallel to BC, like in that way we are taking, we are assuming. This is wrong. But what is correct? L is parallel to BC is the correct. Okay. The final answer here I am writing. Yes. So L is not parallel to BC is wrong. Therefore, L is parallel to BC is the right thing to A. That's all. Okay? Yes. Listen to me one more time. This is converse of basic proportionality theorem. Converse means in which theorem we are taking given part that should be changed as required to prove, and in the previous theorem which you are taking as required to prove, that should be changed to given part. This is nothing but converse of any theorem, whatever it is. Okay, thank you for watching. Bye.